All right, so this is just a little screencast video to walk through how I'm going to make the keychains that you guys designed and just some of the things I have to tweak and change in order to get it to work. So there's three here that were submitted. This one's Ryan St. Pierre's. It's super complex and I'll do my best to try and make it, but it may end up being just a tiny bit different. I may have to change things a little bit to be able to machine it easily. This one's Blake Tassie's, which is pretty straightforward. It's a little connecting rod style keychain. And then the simplest shape to make is this one, which is Dante's. And the reason why it's simple is because when you look at it straight on, it's got a straight edge here and a parallel straight edge here. So it's really easy to just clamp and hold in a vise and machine. So first things first, importing this from Onshape into Fusion 360, I'm just going to change the units from meters to inch. I should at this point be working in metric, but that's kind of the way it goes. I've used CAM software in Imperial for so long that I'm kind of just used to it. So the first thing I want to do is, instead of Dante's letters being raised, I'm going to sink them down into the part because it'll be much easier for my CNC to try and engrave that. So if I use the keyboard shortcut Q for press pull, that's what pops up. And I click on it's not seeming to let me do multiple faces at once. Let's see if I can move this around. Maybe I'm going to have to just do one at a time. Let's see if I can hit the shift key, click on a bunch of faces. This might work a little faster. So I'm just holding down shift and clicking all the faces of the letters for his keychain. And then I'll tap Q for press pull, and I'll move them all down the same amount, 0.025. And the only reason I'm doing that is just to make the letters so that they are sunken down in. I could have left it the other way, but this will allow the machine to be able to just face the top flat and then use a sharp pointed tool to go around and trace all that. So the only other thing I'm going to change is I think the diameter of this hole is super small. So it's a 60 thousandths of an inch hole. I'm going to quickly check what the smallest drill bit I have is. And to do that, I'm going to look in my tool library. Accurite tool library, type drill. The smallest one I've got is probably this 3.9 millimeter drill. So that is 0.15 inch. So we'll use that. So we'll just jump back out of manufacturer and back into design. And what we can do is I might be able to go Q for press pull again and click on that. And I have to back up. I'm going to measure this. It is right here. It is a radius of 30 thou and a diameter of 60, and I want to go to 3.9 millimeters. I'm just using my calculator. 3.9 divided by 25.4 is 153 minus 0.06. So I need to add 93 thou. So we'll go Q for press pull again. Click on that side and go 0.046. And if I do I as a keyboard shortcut for inspect and click on it again, now we have a diameter of 92 thou. So it's, I didn't quite get my math right, not a surprise. So we're going to go Q for press pull again, click on it one more time, and goes 0.046. Um, 2.153 divided by 2. So we're going to go and I for inspect, click on the hole, 100 thou hole. Okay, so we know what's going on here. So Q for press pull, we're going to click on this one more time and we're going to go 0.076. And that's too big to fit in the part, so we can't do that. So what we'll do is I'll just have to load up a smaller drill when I get out into the shop. So that's a 100 thou hole. I've changed that. I've just made the font so that it's all sunken down as opposed to sticking out above. And then the next thing we're going to check just to make sure the material is a reasonable size. So it's under 1/4 of an inch thick. So I definitely have something kicking around the garage I can make that with. And what we'll do is hit save and switch from the design environment into the manufacturer environment. So this is where we tell a CNC machine what to do. So we're going to click on setup, and that box that pops up around the material is what you would call your material stock or your aluminum that you're going to machine with, or aluminum in this case. So we have to take a quick look and see what's going on here because it's tried to make it huge. So we can leave the origin the way it is, that little triad. The Z faces up. That's where the spindle would come from, and then X and Y is just like what you do graphing in math class. That's how the machine knows which way the part is oriented. And we're using fixed size box, and we're going to tell the machine that the material we're using is 0.25. Something funky is going on here. So let's go back to setup and model. We're going to click on that. So now it knows what the model is. And this orientation should be correct. I don't know why it's not. Let's try this over again. See what we can come up with. Setup. That already looks good right off the bat. So we have 1.5 by just under 1. So when I switch to fixed size box, it should not jump to something crazy. So Z, I should be able to make 1/4 inch, or so that worked properly. So we're going to use 1/4 inch thick material, and we're going to offset it 25 thou from the top so that we have this material on the bottom to hold on to with our vise. And then we don't want to use material that's so wide. Right now it's 1.5 inches long, and that's fine. We could actually try to make it 1.6, so we have a little bit on each end. Make sure it cleans up perfect. And then 1 inch wide, so that's fine. We don't need to, I'm pretty sure I have something around that size in the garage. So we can click OK. Now what we got to do is choose what tools we want to use and go ahead and machine this all out. So step 1, we can use this facing command. And I can choose the type of tool that I want to use to reduce my search. And tool 25 is my face mill. There we go, 2500 RPM. So most of this stuff is preset because I've used these tools over and over again. So the first tab you see is all the information for setting up the tool, how fast it spins, how fast it travels, all that good stuff. The second tab wants to know what it is going to face. Third tab is just explaining heights. So we're going to machine from the stock top down to the model top. And then passes tab, we should be able to do this just all in one shot. And then pass extension, let's go 2 inches. So hopefully the cutter starts off of the part and goes right across it. Yeah, that looks pretty good. Perfect. So if we jump over here into simulate, that's what the material looked like before anything is made. Cutter will come down and take it off. Now actually I'll turn the tool on so you can watch that again. And then it clears off the top and we're good to go. So that's step 1 done. Now step 2, we use a toolpath called 2D Adaptive, and my go-to kind of roughing tool to get rid of material easily is this 5/16 end mill. It's called a corn cob or a rougher end mill. It's got serrations all around the outside of it so that it makes really fine chips. And stock top, model bottom, and so it has very low tool pressure as a result of cutting really fine chips, and it's easy on the machine and makes for a good finish and cleanup. So going through all these tabs, what we should see in a second is a little blue tool path that shows it go all the way around. Great. So then our last step, actually, if we right click on this and we go create from derived, 2D milling, we can go contour, and it should select the same line and everything, same tool, and it'll just go around and clean it all up and make it look good. So let's simulate this quick. So step 1 is facing it. Then the cutter on the CNC will come around, mill this all out, and then clean it all up. Now, that cut all the way down, so that would have crashed because that cut all the material. So that's the whole reason for why we use the simulate button. So it went stock bottom minus that. So that should have actually been model bottom and with no extra taken off. And now if we look at the blue line, it's flush with the bottom of the part, so that's perfect. So the next part that's a little bit tricky is figuring out how we're going to try and engrave or trace out those letters. So we go 2D, trace. I think the only tool I have that's set up that works properly for this is tool 28. And what we want to try and click on is all of these top lines for the letters. And this tool works really well. It's spring loaded, so there's a bit of forgiveness. That way, if the part you're working on isn't absolutely perfectly flat, you still get a good finish. I use it all the time. We have the same one at school that I do have at home. So tool 28 is chosen. All the things to engrave are chosen. This should be model top, down, negative. And we'll go. Okay, that looks pretty good. So we'll go back to simulate. We'll just skip through the first couple and hit play. And it looks like the cutter is not. Oh yeah, okay. So if I turn the model off, it doesn't show anything happening. So maybe I just have to adjust the height, but what we would see is it going around and just speed it up and engraving out the DC PhotoWorks logo. So that's good there. Now our last step is to use the drill tool path. Head back to the same library and filter by drill bit. And the smallest one I had loaded I could pick for now, but I will have to load a different drill bit so you can see it's actually going to wreck the part. So I'll have to load a different drill bit, but this will just at least show you guys. And then we go drill tip through and we add a little bit of extra so that the hole is clear all the way through. Now I'll find a smaller size drill bit and program it so that it doesn't wreck the part, but this is just to show you kind of how the process works. So we'll have there, engraved, and then a hole punched. And you can see it's gone gray because it's actually eaten into the model. So if I were to turn this off, you'd see that there's a hole there. That's what would happen if I use that drill bit, but that's okay. We'll switch it out for a bigger one. So there you go. That's how we're going to get going on making Dante's keychain. Now these two, Blake's and Ryan's, are substantially more involved, quite a bit more difficult. So I'll have to pick away at these a little bit and then just use the timeline bar at the bottom to show you guys how I make it. And hopefully I'll have video of the machine running soon and post it up for you guys to watch.